Okay, so we've learned how to add, subtract, and multiply matrices, but we haven't talked about dividing matrices at all. Well, that's because you really can't divide matrices. So what we have to do instead is use the inverse matrix. So that's what we're going to learn how to do today, is to find the inverse matrix so we can use it to kind of divide in the future. The first thing I want to talk to you about is identity matrices. It's not really something that you're going to have to know, but some people get curious, what is this inverse matrix and where does it come from and blah, blah, blah. Basically what happens is if you multiply a matrix times its inverse, you end up with the identity matrix. And an identity matrix is just a matrix that has ones on the main diagonal and then zeros everywhere else. So this is an identity matrix of a 2 by 2. This is an identity matrix of a 3 by 3. So again, not going to be tested over that, but it's just some people ask, where does this inverse matrix come from? That's where it comes from. Finding the matrix that when you multiply it by the original one, you end up with the identity matrix. Okay, so let's go on to inverse matrices. Let's pretend that we were given a matrix that had elements A, B, C, and D. Finding the inverse matrix is kind of a three-step process. Before we get to that, let's talk about the notation. When you see the matrix letter with a -1 exponent, that's the notation for inverse. So whenever you see the -1 exponent, that's the notation for inverse. That's telling you they want you to find the inverse. Okay, so the 3 steps to the process. Number 1, find the determinant. If the determinant equals 0, then no inverse exists. So we just love 0 more and more every day. If the determinant is 0, then the inverse matrix doesn't exist. And you can stop right there and say does not exist. Let's talk about why that is. Because what you're going to do with that determinant once you find it is you're going to put 1 over the determinant. Well, if this is 0, then you have 0 in the denominator of a fraction, and we can't have that. We've been taught that since elementary school. So if the determinant is 0, then the inverse matrix doesn't exist. So that's step number 1, find the determinant. Step number 2 is create what I call the funky matrix. Okay? To create the funky matrix, what you do is you take the numbers that are on the first diagonal, the top left diagonal, and you switch those. Then you take the elements that are on the other diagonal and you simply change the signs. So you're not switching the location, you're just changing the sign. So this is what I call the funky matrix right here. I took the first diagonal, flip-flopped to those two. I took the second diagonal and just changed the signs. Then step number 3 is that you're going to multiply 1 over the determinant times your funky matrix. Okay, and that's going to be scalar multiplication because this is just going to be a number. So you're just going to multiply each of these things by that 1 over the determinant. Okay, so let's do an example. If I have this example here, if I give you the matrix M, -2, 2, 5, -4, and then this is the problem that you're given, then that means that they want you to find the inverse of matrix M, right? That's what that notation means. So let's go through the 3 steps again. Step number 1, find the determinant. Okay, so our determinant is -2 times -4, which is +8, minus 5 times 2, which is 10. So 8 minus 10. So that's -2. So our determinant is -2. Step number 2 is to make our funky matrix. And again, the way that you do that, You switch the numbers on the first diagonal. So that's -4, -2. And you change the signs of the numbers on the second diagonal. So this becomes -5, -2. Third step, we multiply 1 over the determinant times the funky matrix. So again, this is just scalar multiplication. So I'm going to multiply -1/2 times each of these. And remember, -1/2 times something is basically that thing just cut in half. And then because it's negative, we're going to change the sign. So -1/2 times -4. Half of 4 is 2. Negative times a negative is positive. Half of 2 is 1. Negative times a negative is a positive. Half of 5 is 2.5. And a negative times a negative is positive. Half of 2 is 1 again. And a negative times a negative is positive again. So the inverse of matrix M is 2, 2.5, 1, 1. All right, one more example. We have a B matrix down here that's 2, 4, 1, and 3. So again, step number 1, we have to find the determinant. So our determinant is 6 minus 4. First diagonal minus second diagonal. That equals +2. Second step is to find that funky matrix. So flip the numbers on the diagonal, 3, 2. Change the signs, change the signs on the second diagonal. -1, -4. And step number 3 is to multiply 1 over your determinant by your funky matrix. Half of 3 is 1.5, or 3 over 2, whatever makes you happy. Half of -4 is -2. Half of -1 is -1/2, or -0.5 if that makes you happy. Half of 2 is 1. So the inverse of B is this. And again, what does that mean? That means if I were to multiply this matrix times this matrix, I would end up with that identity matrix. So that's what an inverse matrix does. It allows you to end up with this identity matrix that can help us to basically kind of divide without calling it division.